In this session, let us discuss about the impossibility of certain constructions. We are making use of the results of the previous session theorems. The first example, show that it is impossible by straight edge and compass alone to trisect 60 degrees. So here we need to trisect an angle of 60 degrees. That is, we need to construct an angle equal to 20 degrees. So an angle theta is said to be constructible if a line segment of length magnitude of cos theta is constructible. Here you can take any other trigonometric ratio also. Since a segment of length magnitude of cos theta equal to magnitude of cos 60 and that is equal to half is constructible, because half being a rational number, it is constructible. Since cos 60 is constructible, it follows that 60 degrees is constructible. Here we are taking cos function because cos 60 is a rational number. Whereas if you take sine 60, it is root 3 by 2. So there comes root 3, an irrational number. So for our calculation purpose, let us avoid irrational numbers. So to trisect an angle 60 degrees is same as to construct an angle of 20 degrees. Since it is equivalent to construct a line segment of magnitude of cos 20. So instead of considering magnitude of cos 20, we can consider just cos 20 because 20 degrees is an acute angle and cos 20 is positive. So let us consider the identity cos 3 theta equal to 4 cos cube theta minus 3 cos theta. So this is a well-known identity. Let us put theta is equal to 20 in this identity. When we put theta is equal to 20, on the left-hand side we get cos 60 equal to 4 cos cube 20 minus 3 cos 20. Since cos 60 is half, let us replace cos 60 by half and let us substitute cos 20 is equal to alpha. So we get half equal to 4 alpha cube minus 3 alpha. Let us cross multiply this 2 to the right hand side and we get 1 equal to 8 alpha cube minus 6 alpha. Shift this 1 to the other side, you get 8 alpha cube minus 6 alpha minus 1 equal to 0. Thus alpha satisfies this cubic polynomial. Since alpha is the 0 or it is a root of the irreducible polynomial 8x cube minus 6x minus 1, which is of degree 3 over the field Q of rational numbers. Let us adjoin this alpha to the field Q and obtain Q of alpha. And this Q of alpha over Q will have degree equal to 3 since alpha satisfies a cubic polynomial. And this 3 cannot be written as any power of 2. That is, it cannot be written as 2 power r for any non-negative integer r. Therefore, a line segment of length alpha equal to cos 20 is not constructible. So this we have seen in one of the theorem which we studied in the previous session. That is, if Q of alpha over Q is having a degree n and n is not equal to any power of 2, then this alpha is not constructible. Therefore, alpha is equal to cos 20 is not constructible, hence alpha is equal to 20 degrees is not constructible. And therefore, it is impossible to trisect 60 degrees by straight edge and compass. Now let us move on to the second problem. Show that it is impossible by straight edge and compass alone to duplicate a cube. So what is the meaning of duplicating a cube? So duplicating a cube is to construct a cube whose volume is twice that of the given cube. So if you are given a cube of x cubic units volume, you need to construct a cube of volume 2x, right? Without loss of generality, let us consider a cube having a side of unit length so that it will have volume to be equal to 1, that is unit volume. So let us take a cube of unit volume. You need to construct a cube of volume equal to 2 units, 2 cubic units. So we know that the volume formula for cube is length into breadth into height, that gives us length cube, right? So let us take alpha to be the required length of the cube and let its volume be 2 units. So we get alpha cube is equal to 2. So now you need to construct such alpha length line segment. So shift this 2 to the other side, you get alpha cube minus 2 equal to 0. So from here we get alpha is equal to cube root of 2. And this is the 0 of this cubic polynomial. And this cubic polynomial can be written as x cube minus 2, which is of degree 3. And it is irreducible over the field Q of all rational numbers. Let us adjoin this alpha to Q and obtain Q of alpha. And this Q of alpha over Q is having degree equal to 3. And this 3 cannot be written as any power of 2. Therefore, it is not possible to construct a line segment of length alpha, that is cube root of 2. And hence, we are unable to construct a cube whose volume is 2 units. Hence the result. Now, let us move on to the third example. Show that it is impossible to square a circle by straight edge and compass alone. What is the meaning of squaring a circle? That is, if you consider a circle of certain area, you need to construct a square of the same area. That is known as squaring a circle. So without loss of generality, let us consider a circle of unit radius. Since radius is equal to 1, area becomes pi. Since the circle area is pi now, you need to construct a square whose area is equal to pi units, pi square units. So let us assume the side to be equal to alpha. Therefore, area of this square becomes alpha square. So we need to construct alpha such that alpha square is equal to pi. So let us consider that alpha square is equal to pi and pi square minus alpha square minus pi equal to 0. Since pi being transcendental over q, because pi does not satisfy any polynomial over q. Since it is transcendental, we have seen that any transcendental number when adjoined to q, it will that certain field will have, that is the adjoint field will have degree equal to infinity. Therefore, q of pi over q is infinite. Since this is infinite, there is no discussion of whether we can write this as some power of 2. Therefore, alpha is equal to root pi is not constructible and hence the result. So you can't construct a square whose area is equal to pi units. Next, let us move on to the next example. Prove or disprove that a regular pentagon is constructible. Either we need to prove that it is constructible or we need to disprove that it is not constructible. We know that the exterior angle of a regular pentagon is 2 pi by 5, that is 72 degrees, because the interior angle is 108 degrees. So instead of discussing whether 108 degrees is constructible or not, let us discuss whether 72 degrees is constructible. So a regular pentagon will be constructible if it is possible to construct a line segment of length alpha, which is equal to cos 2 pi by 5. So cos 2 pi by 5 can be written as 72. So alpha is equal to cos 72. And this cos 72 can be expressed as cos 90 minus 18. And we know that cos 90 minus theta is sine theta. Therefore, we get sine 18 degrees. So once again, even here you can consider either cosine or sine angle, right? If you take cosine in the beginning, later on you are going to get cos, but you must know the value of cos 18. So sine 18, we all know that it is minus 1 plus root 5 by 4. And in the previous session, we had seen that root 5 is constructible, hence minus 1 plus root 5 by 4 is constructible. Since this is constructible, sine 18 is constructible. Since n 18 is constructible, cos 72 is constructible. That is, the required alpha is constructible. Hence, a regular pentagon is constructible. Now let us move on to the next example. Show that a regular hexagon is constructible. So a geometric figure of 6 sides. Once again, we know that exterior angle of a regular hexagon is 2 pi by 6, that is 60 degrees, because the interior angle is 120 degrees. So a regular hexagon will be constructible if it is possible to construct a line segment alpha is equal to cos 2 pi by 6. We know that cos 2 pi by 6 is 60 degrees. So alpha is equal to cos 60, and we know that cos 60 is half. And half being a rational number, it is constructible. Therefore, alpha is constructible. Since alpha is constructible, regular hexagon is constructible. Now let us move on to the next example. Show that a regular heptagon, that is a 7-sided regular figure, is not constructible by straight edge and compass alone. We know that an exterior angle of a regular heptagon is given by 2 pi by 7. But if you consider this angle in degrees, it will be not a whole number. So it is having some minutes and seconds. So let us consider this angle as it is, that is 2 pi by 7. So let us see whether a line segment of alpha is equal to cos 2 pi by 7 is constructible. Let us consider this 2 pi by 7 is equal to theta. So let us cross multiply. You get 7 theta is equal to 2 pi. So let us write this 7 theta as 4 theta plus 3 theta and shift that 3 theta to the other side. So this is only for the discussion purpose, because we require a polynomial wherein we can say that the degree of that polynomial cannot be expressed as some power of 2. So 7 theta as it is, we can't use any trigonometric identity directly. So let us split that as 4 theta and 3 theta and apply sine on both sides. You get sine 4 theta is equal to sine 2 pi minus 3 theta. 2 pi is 360 degrees. Sine 360 minus theta will be in the 4th quadrant and sine is negative there, and you get minus sine 3 theta. Now you shift this minus sine 3 theta to the left hand side and apply for sine 4 theta, that is the identity cos 2x is equal to 2 sin x cos x. Let us apply that for sine 4 theta. So you get 2 sine 2 theta into cos 2 theta, and sine 3 theta is shifted to the left hand side. So we get plus sine 3 theta is equal to 0. Now let us convert all these multiple angles to angle theta. So sine 2 theta can be written as 2 sine theta cos theta. Cos 2 theta can be written as 2 cos square theta minus 1. And sine 3 theta can be written as 3 sine theta minus 4 sine cube theta. So in each and every term we have sine theta. Let us divide throughout by sine theta and reduce it to 4 cos theta into 2 cos cube cos square theta minus 1 plus 3 minus 4 sine square theta equal to 0. Let us convert this entire equation in terms of cos theta. You can convert it into sine theta also, but here we are going to get a term containing cos cube theta. So instead of converting cos to sine, let us convert sine to cos. It is easy because you have a term containing sine square alone. So sine square can be written as 1 minus cos square theta. On simplification, we get 8 cos cube theta plus 4 cos square theta minus 4 cos theta minus 1 equal to 0. So let us convert this into an algebraic expression by putting cos theta is equal to x. So we get 8x cubed plus 4x square minus 4x minus 1 equal to 0. So let us once again substitute 2x is equal to y so that the highest degree polynomial will have coefficient equal to 1. So we get y cube plus y square minus 2y minus 1 equal to 0, where there are too many substitutions. So we can write this as y is equal to 2x and 2x is 2 cos theta and 2 cos theta is 2 cos 2 pi by 7. And this polynomial y cube plus y square minus 2y minus 1 is irreducible over q and it is having degree equal to 3. Let us adjoin this y to q so that we can argue that septagon is not constructible. So y is equal to 2 cos 2 pi by 7. So let us take cos 2 pi by 7 as alpha. So we get y is equal to 2 alpha. Let us adjoin this 2 alpha to q and we get q of 2 alpha, and this over q is having degree equal to 3 because this 2 alpha is equal to y satisfies a cubic polynomial over q. And this 3 cannot be written as any power of 2. Therefore, 2 alpha is not constructible. And from there we can write alpha is not constructible. Since alpha is not constructible, that is cos 2 pi by 7 is not constructible. Since cos 2 pi by 7 is not constructible, 2 pi by 7 is not constructible. That is, the exterior angle of a regular septagon is not constructible. Hence, this heptagon is not constructible. So, this is how we discuss the construction related problems using the condition for constructibility which we discussed in the previous session.